Dear students, welcome back to the video lecture of module number 5, chapter number 2, nanomaterials. This is the last part of your engineering chemistry course. What are nanomaterials? The word nano is taken from the Greek language. The prefix is dwarf. It is something extremely very small. So for analogy, nano size, how we can represent in the various parameters. 1 nanometer is equal to 10 raised to minus 6 millimeter, or this is equal to 10 raised to minus 9 meter. So how the nanomaterials are made? Combinations of atoms or molecules to form the objects in the form of nanoscale. So these nanomaterials are studied under the broad area of nanoscience. The nanoscience deals with the scientific study of the objects in the size of 1 nanometer to 100 nanometer range, at least in one dimension. Then what is nanotechnology? The engineers are going to produce the nanomaterials with the support of nanoscience. So nanotechnology is the creation of functional materials or devices and the systems through control of product in the nanometer scale, that is from 1 to 100 nanometer length, with the possible practical application. Then how can define nanomaterials? I mean to say, what are nanomaterials? According to IUPAC, nanomaterials are the set of substances where at least one dimension is less than or approximately equal to 100 nanometers. Or nanomaterials are the materials having at least one dimension in length, width or height in the nano range, that is from 1 to 100 nanometer. To define the nanomaterials, the classical mechanics fails. Here, quantum chemistry plays an important role. Why the properties of nanomaterials, they are changing as compared to the bulk materials? The important facts, the properties are changes when you convert the bulk material to the nanoscale. The important reasons are what? The first one is the electron confinement or quantum effects. So this is elaborated by taking a specific example. You take a lion or tiger which is moving in forest. As you know that the forest area is very large, so therefore the lion or tiger which has the very large area of freedom of movement or degree of freedom of movement, but the same lion or tiger, when it is brought under the bar, then the movement is restricted. As the movement is restricted, the property of the lion is going to change because it is restricted for the within specific small area. So likewise, so electron confinement, it plays an important role as compared to the bulk material. In the bulk material, the electrons are not restricted for the movement, but when you reduce them in the nanoscale, the movement is restricted. That is what we can say electron confinement, or it is also called as quantum effects. Then second point is greater surface area to the volume ratio. The volume remains same when you compare with the bulk material and the nanomaterials, but there is a large area of the surface which is exposed for the availability. And third point is reduction in solid state defects. If there are any imperfections in the bulk material, they have been totally avoided when it is reduced to the nanoscale. And last point, the surface and interface forces become dominant. So here, the larger surface area, more atoms or ions or molecules are available for the reaction. Therefore, more force which is exhibited between the reactant and the bare surface. Hence, nanomaterials are playing an important role for making the objects or reactants or catalyst in various field of applications. So why properties are going to change in the nanoscale? Here what can see that you have the 3D object, consider a box which is considered as the bulk material now. Cut it in single slice, you are going to get the quantum wall. That is what the 2 dimension. It is like a flat or network like structure. But the same 2-dimensional object, when it is cut along the length, it is possible to get the quantum wire that is in 1 dimension. Then small part of the quantum wire, when you make it to separate, it forms the quantum dot. So here nanomaterials can be have 4 dimensions, maybe 3-dimensional objects nanoscale, or maybe 2-dimensional objects like the materials 2-dimensional films or plates or a network, or 1-dimensional fibers, wires or the rods, or 0-dimension spheres or the clusters you can have. But in bulk material you are having only 3 dimension, but when the same material is brought to the in the nanoscale, there is one more dimension. That is what you have, that is 0-dimension object. For an analogy, how can express the size of the nanomaterials? You take a human hair, its diameter is 100 micrometer, and cut it along the diameter of 100 slice. Take a single slice from out of the 100 slice is of the size of 1 micrometer. So that 1 micrometer part of that hair is made to 1000 slice. Then separate a 1 slice from that is very close to the dimension of 1 nanometer. A nanometer is 1 millionth of millimeter scale, approximately 1 lakh times smaller than the diameter of human hair. Now how the nanomaterials are going to change from the bulk material? Here you can see that the decorative glaze or luster property, it is what made on the glass pot because of coating of gold nanoparticles on the ruby plot. So here the bulk materials are extremely very small percentage of atoms will be available near or at the surface But in nanomaterials, the large number of atoms or the ions are available for the interference. Now, how we can compare the nanomaterials and bulk material by taking an example of gold. Here in the first column, I have explained about the properties of the gold, what you can observe in the bulk material. But in the second column, I explained about the same gold is converted into nanoscale, how the properties are going to change. First property in the bulk material, lustrous. Gold shows shiny surface when it is polished. Second point, it is malleable, can be hammered, bent or ruled to make it any desired shape. That is what the goldsmith that can do. And it has a ductile property, can be drawn out into a wires, and it is yellow in color, and it has good heat capacity and electrical conductivity, and it has high density and high melting point, that is 1080 degrees Celsius, and it is tough with high tensile strength. And about its chemical reactivities, it is inert, unaffected by air and most of the reagents. Hence what we can say, the gold is an inert metal. But the same gold in the bulk state, when you make it to the nanoscale, there is drastic change in its properties. So vary in the appearance depending upon the size and shape of the clusters, are never gold in color, that is yellow in color, are found in range of colors. As the particle size changes, the colors are also going to change, are very good catalyst for the chemical reaction, are not metals but they are semiconductors. They melts at relatively low temperature, that is at 940 degrees Celsius approximately. And the size and shape of nanomaterials can determine the color of the nanomaterials. For example, the gold particles, when they have been entrapped on the glass surface, how it looks. If the size is 25 nanometer, it looks red reflection. But the same gold nanoparticles of 50 nanometer, they are going to reflect the green color. That is what the light property when those particles are exposed to the visible light. Let us discuss now the properties of nanoparticles. In my presentation, I have shown minimum properties. There are variety of properties are exhibited by the nanoparticles, and few of them I am going to highlight. Nanoparticles properties depends on the size, composition and its structure. Second one, nano size increases the surface area. Then third point, change in surface energy. Always the nanoparticles are having the higher energy as compared to the bulk material. The change in the electronic properties, as I discussed in the introduction. The change in the optical band gap. The change in the electrical conductivity. So nanoparticles are having higher and specific catalytic activity. They have got change in the thermal and mechanical stabilities. And nanoparticles have the different melting and phase transition temperatures. They have the change in catalytic and chemical reactivities. So these are some important properties which are highlighted. For your syllabus, you have around 4 to 5 size dependent properties. How they are size dependent, we'll discuss in our next video lecture. Thank you.